This is the new SpeedyBee F405 version 5 flight stack. Now, SpeedyBee have made quite a lot of noise about the fact that they've ended production of the F405 version 4 and version 3. There seems to be some unhappiness from SpeedyBee that there's a load of clones of those flight controllers coming onto the market, and they've now released this new F405 version 5 as its replacement. What's interesting though about this isn't the fact that it's a new flight controller, it's the fact that the ESC that they're shipping with this is running firmware called OX32, a new closed source 32-bit ESC firmware that we had previously only seen in a flight stack from Oxbot, the people behind OX32. Now, in this video, what I'm going to do is give you an overview of this new F405 stack. We're going to take a look at what comes in the box. We're then going to take a look at this OX32 firmware, its configurator. We're going to talk about what it looks like, try and explain what it might be, might not be, because there is so little information out there around this. And then at the end, I'm going to share with you my thoughts. Just to be clear though, I am not flying this in this video because I need a lot more time to look at this new firmware, test it and play with it than just sit here and say, hey, here it is, you should go buy this. It's not a review, it's an overview. So you hopefully will understand by the end of this video what has actually changed and maybe a little bit about what this OX32 firmware is all about. Okay, so I ordered this in. It took about week and a half, 2 weeks to get to me from AliExpress. This is the big kit. I can't remember exactly what they call it on their website. It consists of the 405 version 5 flight controller. We got the ESC, and you get some extra goodies in this kit that probably most people won't need. So for instance, you have a solder practice board, which is available from SpeedyBee. So if you want to practice your soldering, you've got one of them. It's nice to see it's got all different size pads. So for instance, it's got pads like your main battery ones. It's got your smaller pads. And then you've got much smaller sort of pads here in the middle. The only thing to note on this is I'm not sure what the grounding is like on this. And what I mean by that is on your actual ESC, your negative is going to be heavily tracked into the ESC itself. You'll have big ground areas within the ESC, a lot of copper in there that sucks the heat away. I don't know what they've done on this. We've got plating, but you could still find yourself in a position of you find this easy and an ESC hard. Alongside, obviously, the flight controller and the ESC, we'll look at them in a bit more. We've also got a couple of other weird extras. I'm not exactly sure. We've got this board, which I don't know what this is for, if I'm honest. LED linking board, maybe. I'll have to have a look at that on the instructions. We've got an external USB-C connection. Whilst there is USB-C on the flight controller, you can connect it externally as well, which is nice to see. There's an external buzzer that they've included. Get that out. So you can see that there. And then finally, you've got this little device, which is basically a short saver. Now, there isn't really much instructions for this, but it acts a bit like the Vi-Fly unit. It'll measure voltage. It has cutoff. We'll give it a try and see how it performs in comparison to the Vi-Fly one. And then in the rest of the box, if we bury ourselves into the bottom, we will find some additional accessories. So we have a pre-wired XT60, full-size capacitor, 1000 microfarads. We have our some rubber rings as well as bolts and some isolators, and then we've got our cables, and there's some screws there for your stack mounting and additional cables as well. So look, it's pretty much a typical kit that you get with a flight controller. Now we'll start with the flight controller and then we'll move over to the ESC. So the SpeedyBee F405 version 5. It is a 30.5 by 30.5 flight controller. It is based on the STM32 F405. It uses the ICM 42688P gyro. It now has a USB-C port on. However, it isn't just a normal USB-C. You can see that it is a countersunk USB-C port. They've actually got a cutout on the PCB with the port sits to give a flatter overall footprint. It does have a barometer on board, which is the SPA 06-003. It supports digital FPV, but also analog FPV as well. And it's got the analog FPV OSD chip, the AT7456E. It does, though, obviously support digital FPV as well. And we have some dedicated connectors around here too. It has built-in wireless tuning via Bluetooth, and that is built into the flight controller as well. There is a chipset for that. There is also 16 megabyte of onboard black box storage. The voltage supported on this flight controller is up to 6S. It's got 2 independent BECs on it as well. So there is a 5-volt BEC that supports up to 1.5 amps, and that BEC is controllable as well. You've got a control switch on that, and then there's a 9-volt BEC which supports a total of 3 amp. With regards to the microcontroller and that gyro, it is set up in the sense of it's got a separate LDO, a voltage regulator specifically for them, providing clean power, and it supports various different voltages on board as well, all of the usual stuff that you would come to find on a flight controller. When it comes to UARTs, there are 6 available, although some of these are already tied up. So for instance, UART 1 is tied up via the Bluetooth functionality. You've got UART 2 pads for the receiver. UART 3 is on your digital VTX connection, so Avatar HD, DJI. UART 4 is set up, designed to be used with GPS, and we'll take a closer look what other pads we've got on here in a minute under the microscope. You've then got UART 5 and UART 6 available too. There are also LED pads, including support for the SpeedyBee Meteor LEDs. There's buzzer pads. We've got a boot button on board. You can see there's also the little Bluetooth antenna down there for the Wi-Fi functionality. And then you've got all of your usual I/O located around it, but I think we'll have to get it under the microscope to be able to take a look at them. And then you can see we've got our connections around it with them padded out too, which is really quite nice to see. A couple of other things just to note: you do have various LEDs around the controller, including the SpeedyBee voltage LED system, and the controller comes conformal coated from the factory. You can see that there. We've got a nice glossy look to it as we move it around under the light. Next, we have the ESC, and what is probably the most interesting bit. Now, whilst the ESC in itself isn't particularly interesting, the bit that is interesting is the fact that it is flashed with this OX32 firmware from Oxbot. Now, we know so little about this. We don't know who's made it. We don't know who's tested it. Yet they talk on their website about it being designed by racers for racers and tested. I do know this is being used extensively in China, including in some China racing applications as well. However, we are starting to see it now appear over here. This is the first ESC that I've seen from a third-party manufacturer to have this OX32. They had their own ESC before and flight stack that they were installing the firmware on, but now we have products from SpeedyBee with it, specifically this. Looking around the ESC, there's not a great deal to show you. We're not going to even get this one under the microscope, but what we do have is an ESC that supports 55 amp. It is 32-bit, 4-in-1, 6S voltage max. They have heat shields, aluminium ones on either side, again conformally coated. It's nice to see they've also labeled things really quite well on this, so you can see your motor ports 1, 2, 3 and 4. You've got your main ESC connector up here with everything nicely labeled, and pads for that on the other side as well. And then obviously we've got our motor pads again with everything labeled. We just look, everything is castellated, double-sided and castellated, which is nice to see. Wires through as well on the main battery pads. No wires on the ESC pads. They have included as well 2 holes for a capacitor. You've also got a nice slot down the middle. I like that, a bit of separation. So again, wired, castellated pads on the main battery input. And then it's the same on the ESC as well. Much smaller pads on the bottom, so you're not going to want to solder to the bottom pads. Bigger pads on the top, plenty of space on them too. No one should have any problems there. And they are castellated as well down the sides. Overall, looking very, very nice. Now, obviously, as this ESC is covered in metal shielding on either side, I can't really show you underneath. However, SpeedyBee's website does have a little bit more info. There are copper distribution buzz bars. There are 3 on one side and 2 on the other. The ESC has a built-in TVS diode at the front, and it also has filter capacitors down the middle as well. Again, nothing particularly special about the design, but it is good to see that we can have a bit of a representation of what is going on under the hood. As I mentioned earlier, one of the nice features about this flight stack is the fact that it can be used wirelessly. It has that built-in Bluetooth functionality, and it allows you to configure it via the SpeedyBee app. All you need to do is do a search, and it should pop up. You can then connect to it, and then you can see the options that are available. However, before moving forward, I want to highlight something. SpeedyBee have now introduced an activation requirement. Before I'm actually able to do anything in here, I'm going to need to activate it. So for instance, if I click on here, you can see that it says connecting, and it's now requiring me to activate this before I can use it. Now, activation in drone-related products isn't something that is unusual. We know DJI want you to do things like activate their drones, their action cameras, as well as things even like O4, but this is the first time that I have seen SpeedyBee require an activation before you can use it. I don't like this at all. You need to agree to the terms, and then you need to provide your email address before you can use it. I personally think this is a step too far on the flight controller. I have seen other flight controllers require activation, but usually it's just a click to activate without providing any details, whereas in this case, SpeedyBee are forcing you to provide details, and I don't like this one little bit. Okay, so I finally got it activated. I ended up actually having to put my email in and then register, then put in the code that it sent me on the email, and then it activated. And now, as you can see, it's working, but man, that's a lot of hassle to use a flight controller. Overall, there's nothing particularly special about the flight controller or the ESC hardware, and where things get very interesting is in software. The flight controller itself is designed to be run on the likes of Betaflight, and again, everything here is pretty standard. Where things get interesting is the ESC, because rather than this running either BL Heli 32, AM32, Escape 32, or any of the other ESC firmwares that are out there for 32-bit microcontrollers, instead, this is running something called OX32. This is from a company called Oxbot. Now, they first appeared on the scene a little while ago with their own flight stack based on their own ESC firmware. This stack, called the Oxbot Champ Race Stack, is a traditional flight controller and ESC, but whereas the flight controller was based around Betaflight, their ESC is running their own in-house closed source firmware called OX32. Now, in the marketing material for this, they do seem to be having a bit of a dig at BL Heli 32, specifically around the issues in BL Heli 32 32.9, where you actually couldn't rearm after a crash. Here, they talk about how you can rearm after a crash happening, and there is a little bit more information under their frequently asked questions section, where under the introduction, they say, OX32 is a 32-bit ESC firmware optimized specifically for racing drones, offers efficient motor control, precise response, and intelligent tuning. Developed after the discontinuation of BL Heli 32, OX32 continues to refine motor control strategies based on the needs of racing pilots, enhancing flight performance. They go on to talk about some of the key features, so using DMA optimization strategies, talk about safe soft start, and all of this basic stuff. But what we have here is a closed source ESC software, which they are marketing as a replacement for BL Heli 32. Originally, this ESC firmware was only available on Oxbot's own stack. However, now SpeedyBee seem to be the first manufacturer to include this closed source ESC firmware on their own hardware. To configure OX32, there's an online web-based configurator, a bit like AM32. This is available at ox32.oxbot.com. So as long as you've got your flight controller and ESC powered up, you can select the COM port for your device, click connect, and this will then give you all of the options that are available within the ESC firmware. The first thing to note on this is everything here may seem very familiar. In fact, it is something like 90% of the options in this are identical to the options available in BL Heli 32. Not only are they named the same, but many of them have identical available values as well. So for instance, if we talk about ramp up power in BL Heli 32, that allows you to go down to 3% all the way up to 150%. And that is the same here in OX32. Pretty much everything is identical, not absolutely the same. There are a few extra options in this that there weren't in BL Heli 32. Most of these are options that are broken out from a standard setting a little bit further. However, it is very noticeable just how similar this is to BL Heli 32 from an options perspective. Looking around, obviously under our general settings, you have all of the main options. So we've got motor timing, PWM, frequency, minimum and maximum. You've got your DMAG compensation, your ramp up power settings, your acceleration rate, your brake settings. There's also an expand all to give you some additional options as well. You've got your buzzer settings, your protection, and your telemetry and device info. So again, it is pretty much everything that you will find in BL Heli 32 is also here as well. Along the top, you've then got options for things like motor direction and testing. So that is available here. You've got ramp up sound settings, which is your power on sound. You've got your firmware update options. This is the same as how it worked with BL Heli 32 in the sense of you are uploading firmware from their servers. It does have a use local firmware option, but the reality is the firmware you're going to be using is what is available from their servers. At this moment in time, you've got version 1.1, 1.2, and 1.3, and it tells you there what ESC has been selected. Down the side, down the bottom here, you have a bit more info where it tells us about the port utilization. You do have a contact us button here as well, where you can contact Oxbot directly. We've got our manual, which gives us our full manual for the ESC configurator, as well as a parameters button, which explains to us what each of the individual parameters mean. What is clear is we have an ESC firmware that is designed to be a replacement for BL Heli 32. It seems to have been designed in such a way to at least mimic BL Heli 32 with regards to its core functionality. And if you actually go onto Oxbot's website under their About Us page, they talk a bit more about their team background, where they say they were founded in July 2024, led by a core team with nearly a decade of experience in the FPV drone industry. They focused on developing high-performance 32-bit closed-source ESC firmware. After nearly 6 months of intensive research and development, they engaged over 30 professional racing pilots, 50 freestyle pilots in their product testing. What we don't know is A, who any of these professional pilots are. We don't know where any of this software has been based from. As I've said already, it is very, very similar to BL Heli 32. Do I honestly sit here and think you could go from 0 to a BL Heli 32 replacement in 6 months? I think that is a very big ask. It doesn't appear to be based on any of the open source stacks, such as AM32, Escape 32 or others. But that doesn't mean that there couldn't be something else going on under the hood here. What I do find interesting, and I'll use the word interesting, is just how similar it is to BL Heli 32, especially with all of that functionality with around 6 months of development. Now, I'm not going to be flying this in today's video because I wanted to give an overview first of all, and I really don't think a single video is going to be enough to give you an opinion on what OX32 is like, but I will share with you some of my initial thoughts on what I've seen in a minute. But before we do that, I just want to give you a closer look at this flight controller under the microscope. There's no point looking at the ESC because there really isn't a lot to show you, just so you can have an idea of what the build quality is like from the SpeedyBee stack. Looking under the microscope, first of all, on the top, you can see the microcontroller is covered with this sticker. I'm just going to see if I can get this off to have a look, because I always like to see what is going on underneath. I always have a suspicion of if there's a sticker, what is it actually hiding? Not that I'm saying SpeedyBee are hiding anything here. However, I prefer to see what is going on underneath. There we go. I've got it off. You can't see a huge amount, but you can see the wording on the microcontroller there. Because it's conformal coated, it's somewhat being hidden, but you can see there STM32 F405. Right, looking around the rest, we're going to have a hard time reading part numbers on anything because everything is conformal coated. However, let's go around the pads and have a look at what we got. So let's start here. Along this side, we've got our analog pad. So 5V ground, cam and CC, B plus, B minus, P minus, P plus, and then you got an LED set of pads. Then you got a UART2, so T2, R2, 4.5V as well as ground. Then you've got ground 5V S5, which is motor port 5, ground 5V S6, so motor port 6. We've got another ground 5V and a D pad there next to that. Down here, we've got lots of LEDs, FC, BT, SW. So there's 2 there, and then there's 6 LEDs there. Another set of pads, LED. 9V pads there. Interesting, probably for the back switching. Then along this side, we've got ground, T4, R4, SDA and SCL, so we have I2C on this as well, which is great to see. So you can use this with GPS and have proper compass. You've got your 5V, VTX, ground and S-bus, 9V, ground, T3 and 4. So that's your digital VTX connections there. And then UART6, as well as some additional pads. And another set down there. We've got our voltage LEDs, our boot button. You see our barrow there. And there is our Bluetooth antenna for our wireless control. And there's some additional pads over here. That's probably an ESP32. Ah, I just caught the logo. Yeah, it's definitely an ESP32. Come on, where's the light? You can see the logo there. For the Bluetooth functionality. There you go. Cool. Right. Flipping it over to the other side. Everything here is conformally coated as well. There you've got your 16MB WinBond flash chip. Flick that around. You can see that in a bit more detail. There you go. 2501. There you go. We've got our analog OSD chip there. AT7456E. So you can see that one's 2. And then we've got our connectors. So you can see there, HD unit plug. So that's your DJI, your Avatar HD. Pad there for barrow. Okay. Don't really know what that's about. We might have to look at the instructions. Some additional pads. And then you got your GPS port. So that's GPS, SDA, SCL, T4, R4 and ground. Then we've got our motor outputs to our ESC. So you can see VV, ground, ground. 1, 2, 3, 4. As well as some other pads. And then coming back around here, you've got a couple of extras. G and D, D plus in. And then we've got another UART over here. That would probably be your receiver. or something else. This barrow connector is actually for enabling and disabling the barrow. By the look of it, it's actually a set of pads. They're soldered over, so it's working, but you can unsolder them to disconnect them. I'm guessing so that will free you up an I2C port, I guess, is what that will do. But that is there as well. Bit strange, not typical, but it is interesting to see. And then if we just look around the bottom of this a little bit, just to give you an idea of the layout, you've got your 9-volt back over here. They show you this on the website. And then you've got your 5-volt back there in the middle. And then you've got your internal 5-volt back at this end here. And then you've got external pads. These are your external pads for your USB-C connector on the side. So if you were to break the USB-C off, don't worry. You can manually wire to the board if you want to. As I said at the start of this video, I'm not going to be flying this today. It was more of an overview. In the next video, in a couple of weeks, I'd have flown it, and I'm going to share with you my thoughts on the ESC firmware itself. Then, ESC firmware is far too complex to just make a video and say, hey, it seems okay or not. It needs time. There are people out there who have been flying the Oxbot stack. As I understand it, it seems to be flying very well. They've not had many complaints. There is obviously a huge amount of question marks around this firmware. I'm going to be honest in saying I am highly suspicious about this ESC firmware. And what I mean by that is it looks a lot like BL Heli 32. The settings are basically identical. The ranges are basically identical. And whilst it is possible that they have just made it that way intentionally, and that actually makes a lot of sense, I am highly suspicious around the time frame involved. I am also aware of a few things in the background, such as BL Heli being reversed engineered. And I'm not going to sit here and say Oxbot have reverse engineered, stolen, are using BL Heli 32. But it smells, and unless I had more information, it's hard for me to not be highly suspicious of what this is, just considering how similar it is. It could even be a complete code rewrite designed to have all the same features, but to have someone develop an entire ESC firmware stack in 6 months that has all of the features of BL Heli 32, and it appears to work fine from the information that I've had, is highly suspicious. I would love Oxbot to tell me more. I actually reached out to them before making this video to ask a load of questions, and they have never responded. So unfortunately, I can only tell you what I think, and it smells a little bit is the minimum that I will say around this. Overall, only time will tell, and it's going to take a lot of people testing this for us to really understand what it's like. It's hard for me to sit here and say you should consider this over an ESC that's running AM32 or anything else, because it's just a complete unknown. There are still people flying BL Heli 32. BL Heli 32 is absolutely fine, even 32.9. From the marketing, they were definitely having a bit of a push against BL Heli 32. And in fact, even in their videos on YouTube, they talk about this crash bug issue on BL Heli 32 because they are really pushing this against racers. My understanding is this stack specifically is heavily being used in China in race environments as well. And I don't really know from SpeedyBee what is going on with the firmware. Is it licensed? Is it not? Is it free? We just don't know. The reality is, right now we don't know, but I am suspicious based on what I've seen. Now, if there is anyone out there flying this firmware, I would love to hear your feedback and thoughts. Please do put it in the comments section. Any questions you have I may be able to answer on this, please do put it down below. I hope you have found the video useful. It's a hard one for me to sit here and say, wow, this is amazing. Good SpeedyBee flight controller. About that. So if you do have any more info than I have, put it down below and I will try and share that with the community. Now, if you have found this video useful and you'd like to support the channel, please do consider checking out the links to my Patreon as well as buy me a coffee. It is only through the support of my Patreon are we able to keep making content on this channel. And if you'd like to support us, please do consider checking it out. I want to say a huge thank you to all of my Patreons. Genuinely, we would not be able to keep doing what we do on this channel without your support. And if you'd like to support us, please do check out the links down below. Anyway, that's it from me. Let me know what you think. Stay safe. I will speak to you soon.